Good morning, my dear students. Now, welcome to the video number 4. Students, remember, in this video, I'm going to cover the moment of inertia of rectangular bar, annular ring, disc, solid sphere, like that. There are 4 derivations are there for you. Normally, in this chapter, they are asking the derivation for the moment of inertia of a rectangular bar, annular ring, disc, or any solid sphere and all. This is one possibility. And another possibility is what? State and explain, that is parallel axis theorem and perpendicular axis theorem. And third one is what? Angular momentum and all that is there. That I will explain it in the next video and all that. Okay, now listen carefully now. Before that, moment of inertia, I told you in the previous video and all that, it depends upon what are the factors it depends. It depends upon, first one is, of course, it is not related to this. Don't get confusion. It is. Moment of inertia depends on, I'm repeating this. I'm recapitulating the things what I discussed in the previous class. One is geometrical shape. Geometrical shape. Shape and size. Shape and size. Size means mass. Shape means, is it rectangular bar or disc or ring or any pyramid shape or what it is, or spherical body or something. It is not same. Second point is, it depends upon axis of rotation, that is axis of rotation. Axis of rotation means, now I'll give the example. Is it rotate, suppose this is one disc is there. Now I am rotating about this point, I am rotating like this. Or else it is rotates about this point, axis it rotates. Or else it rotates, assume that here there is a one hole is there and it is passing through it. Now it will rotates like this. These are the examples for the axis of rotation and all that. And third one is, if only can write, here also it depends upon the mass distribution or mass of the object. Mass of the object. These are the things on which the moment of inertia is what depends here. That's why there is geometrical shape, I told you, that's the moment of inertia for the rectangular body, annular ring, disc, they are not at all same and all that. And also it is rotating whether about this point or is it rotating about this end or something that is. That's why it is called as what? Axis of rotation. And also it depends upon the mass distribution. Better to write, don't write mass of the object, better to write the mass distribution, how the mass is what? Distributed and all that. Okay, now let's come to the actual discussion now. First, I am discussing the moment of inertia of a rectangular bar. Read the question properly. Under this, there are two cases are there. Case 1, about an axis passing through its center of gravity and perpendicular to its plane. Assume that it is a rectangular bar. Rectangular bar. Assume that. Now there is one hole, I will make it. Then it is an axis is passing through it. Now it rotates like this. Is it not rotating? Is it axis is not passing through its center of gravity here? That is what? Center of gravity. Now I am taking one rod. I am taking the length of the rod is this length. I will call it as a what? L by 2. L by 2. This length is also L by 2. I think it's clear for you, that is. And it is rotating about what? About the axis x dash. It is what? Rotating. Now what I am doing is, I am writing the length of the rod equal to, now discussion starts now. Length of the rod equal to capital M. Entire length of the rod. If you want, you can give the namings also, you can give M, N, P, Q, you can give any one that is. Then length of the rod equal to what? L. Then mass of the rod equal to M. per unit length, I am writing mass per unit length equal to m divided by what? Yeah, what is the meaning of it? Suppose this rod is there, this mass equal to what? 100 gram. Then length equal to what? 5 centimeter. That means per centimeter how much it is there? It is m equal to m by L equal to 100 by 5 equal to 20 gram. What is the meaning of this? For every 20 gram, the mass of this rod is how much it is? 20 gram. This is notation is a small m. I will call it as a what? Mass per unit length. This notation is small. Yeah, that's important. In all the derivations, I am using this term m. That is called as linear density. Sometimes it is called as a linear density also. Mass per unit length. Okay, fine. Next is what I am doing is, in this rod, I am considering small part of it. I am considering. This is the small part of it. This is the small part. This thickness is dx. Thickness is what? Dx. Now I am considering this rod, this small part is there now. This distance is what? X. This is the distance is what? X. Here I am assuming that this small part will be what? Of course, when the entire rod will be rotates, when entire rod rotates, this small part is also what? Rotates. Here, this small part is at a distance of how much it is? Is at a distance of what? X is there. Then, movement of inertia of a small element, then mass of the element equal to that, or else thickness of the imaginary element equal to what? Dx. Thickness of the imaginary element equal to how much? Dx. Then here you see small m is what? Mass per unit length. Then mass of the imaginary element equal to mass of the imaginary element or small part equal to, how to write? This is m by what? L per unit length into what? Dx. Whether you followed or not, I don't know that is. Just now I told you that is. The rod is there. This rod, m equal to what? 100 gram. It is what? 100 gram. This whole length is how much? 5 centimeter. Then small m equal to what? M by L. 100 divided by 5 equal to what? 20. 20 gram. What is 20 gram here? Per centimeter, it is 20 gram. Suppose I am considering this length. This length is 2 centimeter. Then what is the mass of this part? That is 20 into what? 2 equal to what? 40 gram. This is what? How to calculate? What is 20? Mass per unit length. What is 2? The length. In the same fashion, I have written here m by L into what? Dx. What is dx? Dx is a small element. Please listen carefully, because this part I am using in all the derivations. I will not explain those things again. Then, what is m by L here? Mass per unit length. Per length, what is the per unit or per centimeter or per meter? What is the mass of this? That is m by L into what? Dx and all that. Next, I think it's clear for you guys. Now, movement of inertia. Of imaginary element equal to, what is the formula for the moment of inertia? Mass multiplied by what? Distance. Square of the distance. That is m by L into what? Dx into what? X square. What is x square? The distance between the axis and the element. But you see, I am interested in calculating the moment of inertia for the entire rod. But here I am calculating only for the smaller element. This smaller element, just I will cut it. This one portion. Next is second. Next one is third. Next one is fourth. Like that. You have to take for all the smaller elements. For that, in mathematics, I am taking the integration. Now, moment of inertia of the rod equal entire rod integration of this. What is this? M by L. Just I'm reshuffling the terms. X square into what? Dx. Students, you see, I am integrating from this point to what? This point. Here it is minus L by 2. This is plus L by 2. This is the lower limit and this is what? Upper limit. That's why I am considering minus L by 2 plus L by 2. Here M by L is a constant. Now I am writing I equal to M by L. Integration of x square into dx equal to what? X cube by what? 3. Then lower limit is how much? Minus L by 2. This is what? Plus L by 2. I think you understand. Here M by L is the constant. What is left within the integration? X square into what? Dx equal to what? X cube by what? 3. Now substitute the upper limit and lower limit and all that. Now constant I equal to m by 3l. 3 I am taking outside. Then within the bracket x cube raised to minus L by 2 plus L by. Now I equal to m by 3l. L cube divided by what? 8. Is it right? Then minus of minus plus, it is L cube divided by what? 8. How many L cube by 8 are there? 2 terms are there. Then I equal to m divided by 3l into 2 into L cube by what? 8. Now we know that this part and this is to be get cancels. Here 2 1 ja, 2 4 ja. Then 3 4 ja what? 12. Then what is left? I equal to, can I write? I equal to m L cube divided by, no, not L cube, 1L get cancels. What is left here? mL square divided by what? 12. This is the formula for the moment of inertia of a rectangular rod about an axis passing through its what? Center of gravity and also perpendicular to its length and all that. Very easiest derivation and all that. And one more derivation is there, that is now the axis is passing at one end. At what? One end. And also perpendicular to the rod here. That I'll see it, how to calculate that. Okay. Students, in any equation you see, whatever the term is there other than the mass is this part. Whatever it is other than mass factor. It is L square by 12. It is L square by 12 is nothing but K square. Or else K equal to L divided by a root of 12. What is K? In the previous class I told you. It is called as in what? A radius of gyration. It plays a very important role in competitive examination and all that. What is radius of gyration? It is the point where the axis is passing, where it is passing here, where the entire mass of the object is what? Concentrated. It is the point where the entire mass is what? Constant. That distance is called as an what? A radius of gyration. It is L divided by root of 12. That is. Okay. Next one is case 2 I am discussing. Rectangular bar, case 2. Case 2. Axis is perpendicular to length of the rod. Perpendicular to length of the rod. And passing through one end. Now, what is that? See. I will draw the diagram. This is the rod. In two ways we can do this problem. Here, this is the rod. Now, axis is like this. Either this end or else what? This end. If this is the end, then this will be what? Rotates like this. It rotates. I think you can understand. It will be what? Rotates like this. And the length of the rod is here. Axis is like this. This is x dash. This entire length of the rod is what? L I am considering. Here also I am considering the small element I am considering. Small element. This thickness is dx and this distance is what? X. Now, same thing what I discussed in the previous derivation. What is m? M is mass of the rod. Mass of the rod. L is length of the rod. Length of the rod. Then small m equal to capital by L. What is this? Mass per unit length. Mass per unit length. Okay. Then dx. What is dx? Thickness of small element. Thickness of the element. Imaginary element. Don't write equal to sign always in the physics. You put an arrow mark. Many students are writing equal to. That is absolutely wrong. That dx is the what? Thickness of it. Then what is the mass of this part here? Then here the mass of the element equal to, it is m by L into what? Dx. It is the mass of the imaginary element. Element means small part of it. This I considered in the previous class, previous derivation also. Now I want to calculate moment of inertia about x dash. What is moment of inertia equal to what? Mass, this part. It is m by L into what? Dx. This is a mass. What is the general formula? Mass multiplied by what? Square of the distance. It is the distance between what? Element and what? Axis. What is the distance here? X square. But to calculate the moment of inertia for the entire rod, I will call it I dash. For entire rod, integrate the above equation. Integrate the above equation. Now I am writing I x dash integration of what? M by L x square into what? Dx. You are integrating from this point to what? This point. This limit is what? 0. Upper limit is what? L. This is equal to, you see, equal to m by L outside. Integration of x square equal to what? X cube divided by what? 3. What is the lower limit? This is what? L. Now substitute the limits values. I'm substituting. I x dash equal to m divided by 3l, this one, into bracket of what? X cube. This is 0 to what? L, equal to m divided by what? It is one mistake I made. It is not small m. You take this all the terms. It is capital M. You take capital M. Okay, this is capital M. M divided by 3L into upper limit. It is what? L cube. minus of 0 equal to m divided by what? 3l into what? L cube. That means I x dash equal to ml square divided by what? 3. This is the equation for the moment of inertia. Our axis passing through its one end. We can do in this method, and also we can do another method also. I'll tell you what is the other method. Using parallel axis theorem also we can do it. Here there is application of another method using parallel axis theorem. Parallel axis theorem. First, what is parallel axis theorem here? Suppose this one, this is the what? Axis passing through what? X dash. This is the what? Another line. It is parallel. It is y and what? Y dash. Here, this distance I will call it as a what? D. Moment of inertia about y dash equal to, we know that it is because you want to calculate about this axis. This and this, how they are? Parallel. This is the d is the what? Perpendicular distance. You know that this is equal to moment of inertia about an axis passing through its center of gravity plus mass of the object into square of the distance between the two axes. Apply this concept. Now, in this case, the rod here, axis is passing. There is another axis is there here. This axis and this. See, this is the rod. You see, this is the what? Line above. And this is the what? Center. Now, we know that this is x dash. This is y dash. Here, y dash. ICZ, we know that passing through center of gravity. Case 1 here, it is ml square by what? 2. Plus this one, m, distance between this. What is the distance between them here? L by 2. Square means it is L square by what? 4 here. Then take this, it is L square is a common, it is 1 by 12 plus 1 by 4. How much you are getting? It is a y dash equal to ml square. It is a 1 plus 3, 4 divided by 12. What is 4 by 12? 3. So that y dash equal to ml square divided by what? 3. Divided by 3. Because 4 1s are 4 3s. Is it not the previous case? This theorem is applicable especially while solving the many problems. Even you can, in the examination, ask the question, either you can apply previous method or else for this method. But clearly you have to mention this equation you have to mention. This is the equation using the what that is parallel axis theorem and all that. Okay, that is only 2 cases are there. One is passing through what? Center of gravity. And another one is passing through its what? One end like this. It rotates. In both cases, the moment of inertia is what? Different. And what is the radius of gyration? I told you. Except mass, whatever the term is there, this is k square equal to L square by 3. L cube by 3. Therefore, k equal to square root of L cube or L square? Not L square. L square. Okay. It is L square divided by what? 3. I made a mistake here. Not cube, it is L square. Okay. Students, welcome to the second derivation. It is moment of inertia of the annular ring. Here in this, there are 3 cases are there. One is about an axis passing through its center of gravity and perpendicular to its plane. This is the annular ring. This is the plane of this. Right. Now this axis is passing. I think you can understand. It is passing through what? Center of gravity and perpendicular to its plane. Please understand, because in the competitive examinations, the more problems are there on this. Of course, in the university examinations, you never get any such kind of problems, you never get that. Now, about this axis, the ring will be what? Rotates like this. Ring rotates like this. Just like your steering wheel in the four-wheeler vehicle. There is one axis is there, about which a driver rotates the what? Wheel like this. Now, I am considering one ring. I am considering this is the ring. This is the ring. Okay. Here, one axis is passes. This I will call it as a x dash. Okay. X dash. Here, this is the axis, of course, axis. And here, considering I'm small element, I'm considering this thickness is what? Dx. Of course, it is symmetric body. Here, the distance is what? R. What is symmetric? Here, this is the symmetric body. Everywhere, the distance is what? Same only. The radius is what? Same. Here, I will rotate like this. I can't say how many rotations I completed. Suppose if I mark something now, I will mark it now. I will mark it. Now this is, I mark, it is a red color, I marked. Now I am saying that I will make it like this. It completes one rotation because it is coming to the initial point. Again, it is coming to, I am making second rotation like this. Unless I mark it, I can't say how many rotations are completed. That is, I am using the word symmetric because it is going to use for the case 2 and all that. Now, moment of inertia of the, or we can consider mass of the ring equal to mass of the ring, entire ring equal to what? Yeah. Radius of the ring equal to radius of the ring equal to R. Okay. Next, thickness of the small element equal to thickness of the small element. Thickness of the small element equal to what? Dx. Then mass of the small element equal to mass of the small element equal to mass of the small element equal to, I will consider small m. Or some books they will consider dm also, they will consider small. What is the moment of inertia? Moment of inertia of the imaginary element, small element equal to moment of inertia of the small element. What is the formula for the moment of inertia? Mass of this. What is the mass of this? It is m. Difference between small m and capital M, look into it. Capital M for the entire ring, small m considered for the what? Smaller element. Into, what is this? R square. Next, but my object is to calculate for the entire ring, that is. What is R here? R is the distance between this axis and what? Smaller element and all that. Next, moment of inertia of the entire ring equal to entire ring equal to summation of m into what? R square I am doing. Because similarly I am considering small element I am considering. All are at what? Same distance, because it is a circular ring, distance is what? Same. Distance between the center and circumference is what? Same. Here R square is constant. Can I write like this? I x dash equal to R square into summation of what? Yeah. Here I am making summation of m equal to what? Capital M. So that I x x dash equal to m into what? R square. What is I x x dash? Yeah, what is m r square? M r square is the moment of inertia about an axis passing through its center of gravity and perpendicular to its what? Plane. What is the formula? It is I x x dash equal to what? R square. Next, I told you, what is the radius of gyration? Other than m, whatever the term is there, this term I will call it as a what? K square equal to what? R square. Therefore, K equal to what? R. This is radius of gyration for the circular ring. Next, case 2 is there. Now let us study what is case 2 and case 3. Now let us see the case 2. Movement of inertia of the ring about an axis along its diameter. Along its diameter. Previously, it is passing through what? Center of gravity. And perpendicular to its what? Plane. Now we are calculating the movement of inertia. Imagine that here there is a hole. Now axis is passing through it. Okay, I can't do it now. Here just imagine. This is the one diameter. It is like this. It rotates. Or else, along x-axis I am making. Along x-axis. This is x, what? X dash. I can make it either along y dash or else what? Along x dash. It rotates like this. But remember, since it is a symmetric body, along y-axis I will call it as a what? Along, it is I, y, y dash. And this is what? I, x, x dash. Here I am using the theorem of what? Theorem of a perpendicular axis theorem, not parallel axis, perpendicular axis theorem. What is that perpendicular axis theorem? You said that in the last class I told you that is if there are two axes are there, it is the x-axis and this is y-axis and this is what? Z-axis. What is z-axis? Z-axis is passing through where there is a point of intersection of x and y. X ಮತ್ತು y ಎಲ್ಲಿ intersect ಆಗ್ತವೋ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ z axis pass ಆಗುತ್ತೆ. Not only that, it is perpendicular to it. And x and y are in one plane. It is in one plane. And z is what? Perpendicular to it. And just imagine yourself. It is what? The center of this. Getting the point, I think. Okay. Imagine yourself. This is like this is z-axis. This is what? Y-axis. And this is what? X-axis. Here it is immaterial. Whether you are rotating the ring like this you are rotating or else you are rotating the ring like this, it is immaterial. Because it is symmetric. It is a symmetric. So that moment of inertia, this is I of what? CZ. But here I of x dash equal to I of what? Y dash. Or else I can write Ix equal to what? I1. Now you see I of center of gravity equal to Ix plus of what? Ix I'm writing. Can I write like this? Here I of center of gravity equal to 2 of what? Ix. Therefore Ix equal to I of center of gravity divided by what? 2. What is the moment of inertia about the center? That is already told you. It is how much it is? mr square. It is divided by what? 2. This is x-axis. Or else for the y-axis also it becomes, it is what? It is y-axis. Instead of writing Ix, I can write what? I1. Here also it is mr square divided by what? 2. Students, I think you understand this. Whatever the center of gravity is there perpendicular to its plane, half of it is there either along x dash or along what? Y dash. Here you should write clearly using what? Perpendicular axis theorem. Using which one? Perpendicular axis. AX, yes. Using perpendicular axis theorem. Here, that is ICZ equal to IYY dash plus IXX dash. Here, this point is important. What is this point? Here, I told you Ix equal to what? Iy, or else Ix dash equal to what? Iy dash. Because the mass is same. Whether you are rotating about this axis or else you are rotating about this axis, it is same. Because the radius is what? Same enough. That's why I have written Ic is equal to Ix plus Iy. Since Ix equal to what? Iy. So that Ic is equal to what? 2i. Therefore, Ix equal to what? ICZ by 2. Here, ICZ equal to mr square in the previous derivation. Moment of inertia of the ring about an axis passing through its center. Just I calculated how much it is? Mr square. It is divided by what? 2. I think understand this. Next, one more case is there about an axis tangent. About an axis tangent, that is what? Moment of inertia about a tangent. This is the ring, like this. In this plane, it is a tangent. That derivation, now I will do it. Okay. Students, now let us consider case 3. Look at it. About a tangent and perpendicular to plane of the ring, it is like this. This is the ring. This is the axis passing through what? Center of gravity. It is the passing through center of gravity. The next, it is perpendicular to its plane about a tangent. No, this is tangent. I think you understand. This is the tangent. And how the tangent is? Perpendicular to its plane. It is like this. Of course, this is also tangent. This is different. Now, this is the situation. How it is? It is tangent and also what? Perpendicular to its what? Plane and all that. Here, whenever I draw the diagram like this, it is like this. If I draw the diagram like this is what? Like this you are doing. If I draw the diagram like this means it is a top view, that is. It is a top view. I think in the advertisement and all that you have seen, the cameras, front view, side view and all that. Look into this. This is how it looks. This is the diagram. If I draw the diagram like this, it is in this view. You are viewing from the top. Now, it is how it is. I said that. Now, it is about a tangent and perpendicular to plane of the ring like this. Of course, one axis is passing. Now, one axis is passing through its. This is x dash. And another axis is there. It is like this. Y. Please draw the same diagram. Of course, in the notes, a little bit may be different, that is. And what is this distance? It is what? R. Now, are there not two parallel axes it is? Here, using the parallel axis theorem, y dash equal to I of center of gravity plus mass of the ring into the perpendicular distance between these two axes is what? R square. Here, already I told you, the axis, what is the moment of inertia? About an axis passing through its center of gravity. The case 1, it is what? mr square. It is mr square equal to m into what? R square. Plus of, this is how much? M into what? R square. So that I y dash equal to 2 into mr square. Okay. Students, now Look at this. That is case 4. Perpendicular to plane of the ring, it is a case 3. Now it is about a tangent and in the plane of the ring. In the plane of the ring means it is like this. This is the one plane. Previous case it is what? Perpendicular. This is what? One plane. Just like your board. It is in XY plane. Now it is like this. About a tangent. How the tangent is? Like this. This is the tangent. This I will call it as y dash. And this is another axis. This x dash. What is the difference? Here, is it not like this? X dash means along its what? Diameter. Along its what? Diameter. And another is what? X is either considered like this or here. This is the what? Time. Now you want to calculate the moment of inertia about the axis what? About the axis y dash. About the axis y dash. Read carefully. This is the case comes into the what? In the plane of the ring. In the plane of the ring, that is. Of course, case 3 are not discussed in your notes, that is. It is like this. Please record properly. It is like this. If I consider like this, it is perpendicular. If I consider like this, it is plane of the ring. This is what? Perpendicular to plane of the ring. This is what? Plane of the ring. Normally it gets to confusion for all the students, including the teachers also. This tangent, I am considering one more axis I am considering. What is this axis? Along the what? Diameter. That along the diameter, here I am using a parallel axis theorem. Using parallel axis theorem. Parallel axis theorem. Here, I y dash equal to passing through its center of gravity, of course. This is I of x dash plus m into what? This distance. What is this distance here? M r square. It is where I x dash is the axis along the diameter. Along the diameter of the ring. Along the diameter of the ring. This we know that x dash equal to m r square divided by what? To case 1, recall it. Now I am writing what is x dash? X dash equal to m of what? R square by 2 plus of what? M r square. So that I y dash equal to 3 by 2 into what? M r square. Here, what is the radius of gyration? Except m term, whatever the term is there, k square equal to 3r square divided by what? 2. Therefore, k equal to square root of 3 by 2 into what? R. Students, this derivation is very, very important. Normally, they will ask this one, case 1, case 2 and case 4 from the point of examination. Case 3 you can leave it. Okay, it is competitive examination is required. Remember, in the ring, case 1, case 2 and what? Case 4 and all that. What is case 1? Case 1 is the what? About an axis what? Passing through its what? Center of gravity. Case 2 is what? Along its what? Diameter. Either like this or else what? Like this. And then case 4 is what? It is like this. It is a tangent. It is like this, tangent. And another axis is what? Along the diameter. Now I want interested in like this. Guess what it is? For this, these two axes, how they are? Parallel. Here, this is I x dash means along the diameter. That I know the equation m r square by what? 2. M is the what? Mass of the ring. This is the what? Distance. What is the distance here? The ring distance is what it is? R square. So that m r. Total it becomes what? 3 by 2 m r square. That's all. Here, from the point of examination, I will tell you once again, case 1, case 2 and case 4, you remember it. Okay, now I'll stop it at this point. In the next video, I will go to discuss another 2 cases. I think it is one is disk and another one is what? Solid spherical body of that. That are the big derivations and all that. Okay, till then, be happy and enjoy. Thank you very much.